last class, we have done with separable equation and also with homogeneous equation. Okay, so we are still in solving first order ordinary differential equation. Okay, so we are proceed with now the next type of differential equation, which is a Z equation. Okay. Okay, so refer to your notes for a Z equation. All right. So the first thing is, how can we identify that differential equation is a Z equation? Okay, so we have a function fxy, which is your differential equation. Okay, suppose that function is in terms of negative m over n, which is a fraction. Okay, then for a Z equation, if we can write m here, a function of m together with dx and a function of n together with dy, and if you can prove that del m over del y equals to del n over del x, then we can say it is a Z equation. Okay, so how can we identify the Z equation? When del m del y equals to del n del x. What is m? What is n? M is a function together with dx and n is a function together with dy. Where does this comes from? Where if we have a differential in terms of a fraction there. Okay, just like this. Okay, so initially this dy dx goes to what? Anyone? Initially, this dy dx, if we can write this expression in terms of a fraction, we can write as what? Negative right? So if we have a differential in terms of fraction, and then we can separate the function together here with m dx and n, okay, where m and n is a function of x and y, okay, then we can say that this function, this differential equation is a Z when del m del y equals to del n del x. So from here you can say that m is what? M equals to 2xy plus 3. So del m del y, you differentiate this m with respect to y. What should you get here?
X.
Okay, so you have 2x. And your n, where n is a function of x and y, is x squared minus 1. Then differentiate n with respect to x equals to also
2x.
Then we can say that del m del y and del n del x here are equal. Then it is a Z equation. Okay, clear. This is how you can prove that the differential equation is a Z, where you identify your m and n first, okay, and then differentiate m with respect to y and differentiate n with respect to x. If both of them are equal, then we can say that it is a Z. So now once you can prove that this differential equation is a exact equation, how can we find the solution? Okay, so looking at the notes here, there are two methods of finding the solution of the exact equation, method 1 and method 2. Okay, let's go one by one here. So for method 1, first, what you need to identify here is, so write the dE in the form of m dx plus n dy. Okay, where it is given here. So this is m x plus n dy equals to 0. And then test the exactness where you test del m del y equals to del n del x. So it is equal, then it is exact. So this is your first step. Okay, second step, if the dE is exact, then m equals to del u del x, n equals to del u del y. So second step, m equals to del u del x, n equals to del u del y. So from here, from the question, your del u del x equals to 2xy plus 3. Del u del y equals to n, which is x squared minus 1. Okay, so this is your second step. Then from here, we can find the solution by integrating this del u, either with respect to x or with respect to y. So for the method 1, for the first method here, you can choose which del u you want to integrate in order to get uxy. Okay, so let's choose so this is first equation, this is second equation. So let's choose first equation, where first equation we have del u del x. So in order to get u, what you need to do? From here to here, what you need to do?
Integration.
Yes, you integrate with respect to what? With respect to x. Okay. If you choose second equation, means that you have to integrate with respect to y because of del y. But for method number 1, you need to choose either one. First equation or second equation depends on the simplicity of the function. Sometimes the function is quite complicated. It is not suitable for integration. Then we don't choose that. Okay. So now for the first method, we just choose any one of the functions then. Okay, so let's choose the first equation here. So integrate this with respect to x. So what should be your u here? Equals to what? Come on.
X square y plus 3x.
X square y plus 3x plus a constant. Right. C, but here let's use psi y here. Okay. Why psi y? Why not psi x? Because here we differentiate, here we integrate with respect to x, and remember your u in terms of x and y, so we assume that we have another constant with y variable. Okay, it doesn't matter, it can be either constant, it can either be a function of x, but we just put that as a variable, okay, as a constant. All right, so now we have your u, x, y, and we have a constant there. So our next purpose is we want to find what is the value of the constant here. Okay, so we want to find what is the value of the constant here. How can we find it? Okay, so now let's take a look. From we have used the first equation, right? So we have used this, and we have second equation. Now you have u. So now from second equation, we need to have del u del y in order to make the comparison. Okay, so from third equation, we can have del u del y. We can differentiate this u with respect to y because we want to make a comparison with second equation. So from third equation, you have u. Now again, differentiate with respect to y. So you should have x squared plus psi prime y. Understand or not? Now you can compare third and second and fourth. Okay, so from second equation, you have what? Del u del y equals to x squared minus 1. From fourth equation, you have del u del y equals to x squared plus psi prime y. So from here, when you compare, what can you see here?
We can know the value of psi prime y.
Okay, we can get the value of psi prime y, which equals to
-1.
yes, -1. So when psi prime y equals to -1, then what if psi y? We just integrate with respect to y because this is y. So psi y equals to -y. Okay, so now from the third equation, you know that uxy equals to x squared y plus 3x plus psi y, and you have your psi y already, then uxy now becomes x squared y plus 3x minus with y. Okay, so we have done with this part. Psi y, and then we differentiate, and then we compare. Okay, and then we get the psi y, and the last one, the solution should be written in terms of uxy equals to a. So your final step is uxy equals to a constant y, because when there is the integration process here, there should be a constant here, right? So we summarize all of the constant value here. Okay, clear? Okay, again, let me summarize the process. Okay, first step, you have to rearrange, right? And then prove the exactness. When it is exact, then you can say that m is del u del x and equals to del u del y. Okay, from del u del x and del u del y here, we need to find uxy. So how can we find uxy? So for method number 1, we just choose any del u here between first and second equation, we integrate. If you choose del u del x, you integrate with respect to x. If you choose del u del y, you integrate with respect to y. Depends on the function simplicity. Okay? And then once you obtain u, you need to differentiate with respect to a function that is left to compare. So before this, you have del u del x, you integrate. And then we still have del u del y. So from u here, you just differentiate with respect to y so that we can compare with the existed del u del y. So once you differentiate, you get your del u del y, then you can compare. Once you compare, you can get the value of psi prime and psi prime y. And then just substitute the value of constant that you obtain in the last answer, and you can write the last answer written equal to a constant. Okay, clear? All right. Okay, now method number 2. Method number 2 is easier compared to method number 1, but it depends on the function. Okay, so let's take a look. First, same process, same example. First, of course, you have to check the exactness. Same process, rearrange, check the exactness. Once it is exact, then m equals to del u del x, n equals to del u del y. Same process. Okay, let's proceed with method number 2. Since you know that it is exact, then we can say that del u del x equals to m. Del u del y equals to n, which is 2xy plus 3, x squared minus 1. 2xy plus 3, x squared minus 1. Okay, I just start with the second step here because the previous step is identical with the first method. Okay. All right, so now from here, okay, from here, what you need to do for method number 2 is to integrate both. Right? So before this, you just integrate once and compare with another one. But for this second method, you integrate both for del u del x. So in order to get u, first you integrate 2xy plus 3 with respect to x. And second, you integrate x squared minus 1 with respect to y. You integrate both because both can give you u. Okay? So for here, you have same like before, x squared y plus 3x plus this one is x, so we have psi y. Okay, and then for the second one, we have first uxy equals to x squared y plus 3x plus psi y. Okay, for the second one, uxy integrate with respect to y, you have x squared y minus y plus psi x. Okay, so the difference between these two u are the value of constant. Here we have psi y, here we have psi x. So now, as you can see, both are uxy. So you just compare. Compare both uxy. So here we have x squared y plus 3x plus psi y equals to x squared y minus y plus psi x. And as you can see, here we have x squared y, here we have x squared y. We just can omit them. Okay, and then psi y is a function of y. So it can be equals to negative y. And psi x is a function of x, then it can be equals to 3x. So from here, we know that psi y equals to negative y, psi x equals to 3x. Okay, then your uxy, you can choose either one. Okay, you can choose either one, first equation or second equation. If you choose first equation, you just substitute what is your psi y. If you choose second equation, you just substitute what is your psi x. So uxy equals to x squared y plus 3x plus minus y. Okay, either if you choose first equation, then you choose psi y, and if you choose second equation, then you put psi x. Both will give you the same answer. So this is your uxy, and the final answer should be written as uxy equals to a constant. Understand or not? This is method 2. Can you, if we write both equation, can both equation will give you the same answer. If you get different answer, then maybe something is wrong somewhere. Okay? You just need to write one because it will give you the same equation. Right? Because our purpose is what? Our purpose is uxy, where it is the solution from del u del x or del u del y. Okay? Clear? Can you see the difference between method number 1 and method number 2? Anyone has question? I need some response, please. Okay, method 2 is more simple for this question. Okay, which method that you can choose is depends on the simplicity of the function. Maybe del u del x is quite complicated. You cannot directly integrate both. Then you need to do the first method. You integrate once, you compare with the differentiation and so on. If both function is quite doable for integration, then you just can proceed with method 2 where you integrate both to get uxy. All right, clear?
Yes, doctor.
Yes, doctor.
Okay, good. So that is how we find the solution for a z equation. Right. Okay, so let's take a look at the notes. We have example 1, solution by method 1. We have example 2, try to solve example by using method 2. So we have done both. All right. So referring to the notes, okay, it is mentioned that what? It is mentioned that if it is non-exact, then what should we do? Okay, some non-exact equation can be turned into exact by multiplying it with integrating factors. So let's take a look. Okay. Now you know how to find the solution of exact equation. Okay. How can we find the solution? First thing first, you need to prove the exactness of the function. Okay, so but if for non-exact equation, what you need to do is to multiply it by integrating factor before we can use the method here. Okay. Yeah. Okay, for non-exact, multiply by integrating. Let's take a look at the second example. Okay, show that xy plus y squared plus y dx plus x plus 2y dy equals to 0 is not exact. Okay, show that first. How can you show this is exact or non-exact? Okay, show this first. Is it exact or not? For second example. Done?
Yes, Doctor.
Okay, so from here, you know that this is your m, right? M, and this is your n. So for exactness proving, then you just need to show what is your del m del y and what is your del n del x. So del m del y equals to what?
X plus 2y plus 1.
Okay, x plus 2y plus 1. And del n del x equals to
1.
1 or 2?
1.
1, right? So you can conclude that it is non-exact. So how can we make sure from this non-exact we can turn to exact? So they are not equal, thus it is non-exact. So then by multiplying both sides with the integrating factor, solve the equation. Okay, so now we need to multiply with the integrating factor given here both sides. So it now becomes exponent x plus exponent x equals to 0 times exponent x, 0. So your new m here becomes ex, xy plus y squared plus y. And your new n now is ex, x plus 2y. Okay, try to show again what is your del m and del m del y and del n del x. Is it exact or not? Okay, you need to use product rule here, right? Okay, what is your del m del y? Differentiate with respect to y, differentiate with respect to m. Right? Where this is equivalent to. Okay, anyone has question up to this part? What is 1 here? Okay, anyone has question? You know how to differentiate this? So now both are equal, then all right. So once it is equal, then it is exact. Then what you can say that your m now is del u del x, which equals to ex, xy plus y squared plus y. And your n now is del u del y, which equals to ex, x plus 2y. Okay, which method that you have to choose between method 1 and method 2, looking at the types of function here? Can you try to integrate both for method 2? Is it doable? Of course, but maybe it takes some time, right? Okay, which method? Method 1 or method 2? Remember, in method 1, you just need to choose one to integrate and then differentiate and compare. For method 2, you integrate both and compare. Okay, so now method 1 is quite doable. Okay, method 1 is the better option. But now you can choose which function that you can integrate easily. M or N, del u del x or del u del y. Right, you choose method 1. And in method 1, you just need to choose one function to integrate. So which function is easier to integrate? M or N? N. Okay, so this one is easier to integrate. Then what you need to do, you can obtain uxy from what? from integrating del u del y with respect to y, and then differentiate uxy that you obtain with respect to x, okay, and compare with the existence, with the del u del x existed in first equation. This is first, this is second, okay. Integrate del u del y, which is second equation with respect to y, and then differentiate u that you obtain with respect to x and compare with del u del x existed in one. Okay, try to follow the process here and obtain your answer. Try it first. If you have problem after this, I can show. Any question? You know how to do it? So I believe everyone can do this. Okay, try it first. I'm going to give you about 10 minutes or 5 minutes now. Okay, anyone has question? Can you do this? Done? You got it? Can you do this, guys? If you have problem, just directly ask, okay? That is the process. No what? No problem or no, you can't do it or what? Cannot do. Okay, let me just say so. Okay, look at the method. This is how I instructed you to do the solution process here. Okay, now for this, we are agreed to choose method 1, right? Why? Because both function is not suitable to do integration. So let's choose method 1 where we just choose one function to integrate, and you choose the second equation here because it is easier to integrate. Okay, so what is your next step? Okay, so next step, you have del u del x, you have del u del y. You choose del u del y here because it is easier to integrate. Why you need to integrate? Because we want to have uxy, okay, uxy, integrate del u del y with respect to y. So in order to get this uxy, you integrate ex with respect to y. So what should you get here? Integrate this with respect to y. This is a constant, right? Because it involves x. So we just put it outside. Then you integrate x plus 2y with respect to y. This is x also is a constant. Then constant, we integrate with respect to y. Then we have xy. And this one becomes 2y squared over 2 becomes y squared. Integrate with respect to y. So we have a constant of psi x. So this is your uxy. Okay, now differentiate uxy with respect to x and compare with del u del x existed in first equation. So from here, you differentiate with respect to x and then you can compare with the first equation here. So differentiate this with respect to x, you should get what? This one is what? This one you just can simplify here. And differentiate. You need to use product rule, right? This one becomes what? EXY plus
EXXY.
EXXY. This one becomes plus XY squared, right? So we can factorize, putting EX outside, then we have Y plus XY plus Y squared, right? Then this one becomes psi prime X, okay? And then what you need to do is to compare with del U del X in the first equation, okay? So then this one compare with first equation where del U del X equals to EX xy plus y squared plus y. Compare with this del U del X that you obtained just now with EX. Okay, try to rearrange the same as the previous one. We have xy plus y squared plus y plus psi prime. So this one is the same as del U del X. Then what we can conclude that psi prime X equals to
0.
okay, 0. So psi prime equals to 0, then psi X equals to integrate 0 with respect to X, you should get what? Integrate 0, you should get what? No, integrate 0, you should get constant. Okay, integrate 1, you should get X. Right? Okay. Now, from here, from UXY, once you already get your psi X, we can write UXY now equals to EX xy plus y squared plus constant. And remember, we need to write in terms of UXY equals to A. So EX xy plus y squared plus C equals to A, and EX xy plus y squared equals to K, where K equals to A minus C. So this is how you find the solution of a Z differential equation. Is that clear? So this is where we use method number 1. Okay, so which method we need to use? It depends on the function. Which method that you can choose to integrate? It depends on the function. Okay, depends on what? Depends on the doable of integration, depends on their simplicity. Okay, so that it will ease the solution process. Is that clear, everyone? Understand or not? Okay, let's review the process. First, you know that this is non-exact after you show that both are equal. Then, what you need to do here, multiplying by integrating factor. Once you multiply again, you prove the exactness. Now, they are equal. It is exact. Once they are equal, then this one is the next process where m equals to del u del x, n equals to del u del y. Okay, so from here, what you need to do is to find u, where you just need to integrate one function between those two functions. When you integrate, you obtain your u. There is a constant. So in order to find the constant, you need to differentiate and compare. Okay, once you compare, you have your psi. Then again, you just substitute. Once you substitute, then the last answers should just equal them to your constant. So this is the process. Is that clear, everyone? Any question?
Yes, doctor. Clear.
Okay, good. Anyone has question? No? Okay. No question. All right, good. So why don't you try the first question for past year question there? This one. Try to do this. Can you do it? Okay, I give you around 10 minutes. Okay. All right. Any question? Which method that you use? I think for this one is method 2, right? Or method 1. It doesn't matter which method that you want to choose. It is up to you actually. Okay. Depends on you. Because at the end of the process, you will have the same solution. All right, you got it or not?
Yes, doctor.
Okay, good. So I believe maybe if not all of you, somehow a part of you can do this. So for those who cannot do it, you can try to ask your friend. All right, so right now I want to proceed with the next type of differential equation here, which is linear. Okay, so this is the answer which I have already shared in the WhatsApp group. So this is the answer for past equation for exact. You can try and then you can compare with the answer. Okay, so the next type of ODE is linear equation, right? So how can we identify the linear equation? Okay, so how can we identify the linear equation, the linear differential equation here? Okay, let's do this together with the first. Okay, now how to identify? All right, the general form of first order linear differential equation is given by this. Okay, so remember this is first order, so it just consists of dy dx, right? So the general form is where, look at the coefficient of dy dx. So the coefficient of dy dx should be 1. And there is a function of x together with y and equals to a function of x. Okay, if it is fulfill this condition, then we can say that the differential equation is linear. Okay, let's take a look at the example here. The coefficient of dy dx here is 1, right? And there is a function of x together with y, which is px here. Okay, and then there is a function of x in the right hand side, which is qx. Right, so it is fulfill the general form of linear equation. Then we can say that this is linear. Okay, it is mentioned already. Solve the first order differential equation. Oh, no, it is not mentioned, sorry. So now this is linear. So how can we find the solution of this linear differential equation? So determine the value first. Determine the value of px and qx. So now you know your px equals to 1 plus x over x. Or we can write them as 1 over x plus 1. Right, you can simplify this. And qx equals to ex over x. So this is your first step. Identify the form, identify the form of linear differential equation and determine the value of px and qx, where you need to make sure that the coefficient of dy dx equals to 1. Okay, then third step, calculate the integrating factor of mu x. So how can you calculate mu x? Mu x equals to exponent to the power of integrate px with respect to x. Okay, so what is px? So integrate 1 over x plus 1 integrate with respect to x. Okay, what should you get here? Come on. What should you get? Integrate 1 over x plus 1 with respect to x.
Ln x plus x plus.
Okay, so you should have exponent to the power of ln x plus x. Okay, where you can simplify this as exponent ln x times exponent x. Then you can write them as x e x. Okay, so this is your mu x. So next, once you obtain your mu x, what's next? Write the equation in the form of mu xy equals to integrate mu x qx dx. So this expression comes from this where you differentiate mu xy equals to mu x qx. So the fourth step here should be what? Mu xy equals to integrate mu x qx dx. So mu x is obtained, y is y, integrate mu x times with qx, where qx is exponent x over x, integrate with respect to x. So this one you can eliminate. This one becomes integrate e to x. So you should get e to x over 2 plus, okay, and from here you can get your answer where y equals to what? 1 over x e x multiplied by, can simplify e to x e x, so e x over 2x c over x e x. So this is how you find the solution of linear equation. First, identify its general form and then determine p and q, and then determine mu x integrating factor, and then write the equation in terms of mu xy, integrate mu x qx here. Solving this and obtain y. Clear? Everyone's clear? Any question? All right, good. So this is linear differential equation. It's quite easier compared to the exact. Exact is not hard, but it's quite a lengthy process, right? So you have to be very careful with the steps. Okay, now, same with the previous type. If you have non-linear, then by using right substitution, we can reduce non-linear to linear. So how? Now let's take a look at the next example. Okay, you can refer to the notes. Okay, you can refer to the notes where non-linear DE can be converted into linear by using the right substitution. Okay, now let's take a look at example 2, where this is non-linear. Okay. And how can you find the solution for non-linear? By using such substitution. Right. Okay, so first from here, using z equals to y squared, convert the following nonlinear differential equation. Okay, you know that this is nonlinear. Why? Because the first one is, take a look at the coefficient here. You need to have coefficient 1. Okay, we can have 1 as the coefficient of dy dx here if you divide everything with x squared y, right? X squared y. Okay, dy dx. Right, if you divide everything here, this one is already 1. The coefficient of dy dx here is already 1. And this one can also be reduced to a function of x with y. But there is y in the function of qx here. So, meaning that this is nonlinear. Okay, so now we have to use the substitution to reduce this nonlinear to linear. So how? Okay, first we have the substitution where z equals to y squared. Okay, now we want to substitute to this differential equation where, as you can see, we have dy dx there. So we need to have dy dx from here. So we have to differentiate the expression here with respect to x. So by implicit differentiation, we have dy dx. And here we have y dy dx. So we can have 1 over 2 dz dx equals to y dy dx. So just substitute x squared. So substitute x squared, y dy dx now is 1 over 2 dz dx minus x, y squared is z equals to 1. Okay. Convert this to general form of linear. So you should have what? Dz dx minus xz equals to 1 multiply with 1 over 2x squared, right? Two. Okay, so multiply everything here with 2 over x squared. So now it becomes dz dx minus 2 over xz equals to 2 over x squared. So as you can see, the coefficient of dz dx now is 1, and this is a function of x with z, and this is a function of x. So you can see that this is linear already, where px equals to negative 2 over x, qx equals to 2 over x squared. Okay, clear now? You got question? Now this is linear. This is linear. Once it is linear, then you can have your Px and Qx. The implicit part, okay, this one. All right, z equals to y squared. So you want to have dy dx. Okay, we can assume that the function z here is in terms of x. Okay, then we can differentiate this with respect to x. So this one, 2y, differentiate 2y with respect to x, you get, differentiate y squared with respect to x, you get 2y. But don't forget this is, we differentiate this implicitly all together, so don't forget dy dx. Just like this, actually, this one we differentiate 1z. So differentiate z should be 1. But don't forget the dz dx part. Okay? Because we implicit differentiation means we differentiate all variables together. Okay? Understand or not? So just substitute here, and then once it is linear, then you can obtain your Px and Qx. So what's next? Once you obtain your Px and Qx, you can find what? Your integrating factor by integrate exponent integrate Px with respect to x. Once you obtain this, you just can substitute to the mu xy equals to integrate mu x Qx. Okay, try. What is your integrating factor? And then what is your the product of integration of mu x and Qx then? Exponent integrate -2/x. X equals to what? Okay, what is your integrating factor here? Anyone want to try?
E negative 2 ln x.
Okay, so e exponent to the power of -2 ln x. Okay, we can simplify exponent ln x to the power of -2, right? Where you can have x to the power of -2. We just can eliminate this, right? Then we have 1/x squared. So this is your mu x. This is your integrating factor. And then by using mu x z, because we have z here, equals to integrate mu x Qx dx. So we have 1/x squared z equals to integrate 1/x squared. Qx is 2/x squared. Okay, so this one becomes integrate 2/x to the power of 4. So we have what? What should we have here? Integrate 2 over x to the power of 4 equals to what?
Negative 2 over 3 x power negative 3.
Okay, plus with. So z equals to right? Z equals to this one becomes minus 2 over 3x plus cx squared. Okay, then remember this is z. And remember what is z? Z equals to y squared. Again, substitute y squared equals to minus 2 over 3x plus cx squared. All right, clear everyone? Anyone has question? Okay, clear. So this is how you find the solution of nonlinear, convert to linear, and then proceed with the process of linear equation solution. Okay, so we have done with two types today. The first one is exact, and this is linear equation. Okay, so any question? From 1 to 10, where are you for these two types of differential equation?
6.
6, 7, 8. What about the rest of you? 6. Need to do more exercise, of course. I cannot show everything during the class session. You need to do it by your own. Okay, good. All right, so now that's it for today. So we have done with exact equation. Okay, and then how to find the solution of non-exact to exact, reduce first. Same with the linear. Okay, understand how to identify so that you can understand whether that function is exact or non-exact, linear or non-linear. Okay, so you need to understand the concept first, the form of the equation first before you can proceed with finding the solution. Okay, so again, please try to do it by your own with the same example that we have discussed, and then after that you can try the past equation, which I already give you the answer in the group, and also try the tutorial. Try the tutorial. The answers are there, so you need to try. You need to make more exercise and practice. Okay, so before we stop, thank you. I will share the attendance. Don't worry. This is the past equation for linear. I have shared this one also in the WhatsApp group. Okay, so before we stop, don't forget to scan the attendance here. Let me open it first. So if you have question, you can directly ask me. We have 54 students for section 46 and the participant for today is 50, 49.